Welcome back to Making Algebra Fun. This is Mrs. Dewar, and today we're going to look at solving systems of equations by elimination. If you've been with me through the first two videos, then you saw the issues that we had with graphing. Sometimes the graphing method isn't perfect because you may draw the lines not perfectly straight and it may be difficult to see where the solution is. Or sometimes the solution may just be in the middle of a square and therefore difficult to tell exactly what it is. We also did the substitution method, which was fine. We did notice that certain times it can be exhausting if you end up having to work with fractions, and we saw one example of how we went through the whole thing working with fractions. I'm going to show you one more method today. This is my personal favorite. This is called the elimination method. So I'm going to take the same equation we have already solved with the previous two methods, and I'm going to show you what this looks like using elimination. First of all, with elimination, what we need to do is stack the equations and line up the like terms. So one goes on top of the other. You want to make sure that x is lined up, y's are lined up, the equal signs are lined up, and the constants at the end. Once you've got that, the idea is to combine the equations and eliminate one of the variables. Now this one is perfect for elimination because it's already set up so that when you add these equations together, the y and the negative y will cancel, and that's the easiest type that you will come across. So let's do that. Let's add the equations together. We get x plus x and we make that 2x. Now y and negative y will cancel. Drop down the equal sign, and then you have to add 3 and 1 to get 4. And when this happens, you are able to eliminate a variable. You can solve the resulting equation just by dividing, in this case, by 2, and so x is 2. Now to go back and get y, we do the same thing we did with substitution. You have to substitute the 2 in place of x in one of the two original equations. It doesn't matter which one. So I'm going to take the first one. I'm going to make x 2. And then I can quickly solve this, and I get y is 1. So the same solution that we've gotten using the graphing method and the substitution method, we now got with elimination. Now here's another example. Always stack the equations and line them up. Always make sure that the x's, the y's, the equal sign, the numbers are all lined up. And if that's the case, then you're ready to go with elimination. Now what we'll pay attention to here is the x's. You can see that the 3x and the negative 3x are going to cancel if we add these together. So let's go ahead and do that. I'm going to cancel those. I'm going to get 6y when I combine the y's. Drop down your equal sign. Negative 7 and 19 is 12. Divide by 6, and y is 2. Now that I know y, I'm going to substitute that. It doesn't matter which one. I'll take the one on the right this time. And we're going to solve for x. So make 2 times 2, 4, and this is just a quick two-step equation, and you get x is negative 5. Always write the solution with the x coordinate first and then the y coordinate. Now, you may think that's great, but what happens when you line them up and nothing cancels? Okay, so these all look good, everything's lined up, but if we add these equations together, the x's won't cancel and the y's won't cancel. And so how do we use the elimination method with a system that looks like this? What we need to do is multiply one or both of the equations to force those coefficients to be the same. If you look at the x's, the idea would be to multiply the top equation, the whole top equation, by negative 2, because I would want to make that front term, that coefficient of x, negative 6. That way it would cancel with the positive 6 that I have underneath it. So I can't just multiply one term by negative 2. I've got to distribute that and multiply every term by negative 2. And it doesn't really matter to me what the rest of the terms become as long as that front term is negative 6. Now I'm going to bring back the other equation that was beneath it, and there it is. So now when you look at them, these do cancel. So let's combine these equations. Cancel those x's, negative 4y and positive 5y is 1y. Drop down your equal sign and combine on the right. So now that we have y, we can take that and substitute it for y in one of the original equations. We know y is 3. We're going to use this to get x. I'm going to take this first equation, but it doesn't matter which one you use. We'll make y equal to 3 and we'll solve it. This becomes a quick two-step equation, and now you have x. So we can see that x is 7, and again, y was 3. So when we write our solution, it's going to be 7, 3. Okay, so here's another one. We want to stack the equations and we want to make sure that everything is lined up correctly, and it is. The thing with this one is you can't just multiply one of the equations and make the x's the same coefficient or the y's. We may have to do both equations. So if you consider the x's, what we could do is make both of the coefficients of x 15, one 15 and one negative 15. And if we choose the y's, we could do that by changing them both to 12 and the other one negative 12. So we have two options here, and it doesn't matter which one you do. So I'm going to solve for y. So think about how you're going to make the 6 a 12. You would have to multiply it by 2. And think about how you'll make the 4 a 12. You would want to multiply it by 3. So that's what we're going to do. We're going to multiply the top equation by 2, and that gives me 10x. Don't forget, you have to do every single term, even the right-hand side. And then the bottom equation by 3, I get negative 9x plus 12y, and on the right, negative 24. So now we're all set because we can combine these. The 10x minus 9x is 1x. Negative 12y and positive 12y cancel. And turns out so does 24, negative 24. It gives us 0. So x is 0. Okay, so we have one of the two coordinates that we need. Now we just need to go back and get y. So either of the two original equations will work. You sub in 0 for x. 5 times 0 is 0. And we can drop that. Divide by negative 6 and you have y. So we write our solution. X is 0, y is negative 2. But what if, when you stack them, things don't line up? You may have to rearrange one of the equations to match the other. So in my first one, I have x, y equals number. In my second one, I have x, and then I'm supposed to have y. So I'm just going to bring the y over to the left and make it negative. And now I have x, y equals number, just like in the first one. So it looks pretty good. Let's line them up. And I can see the x, the y equals number the way it's supposed to be. So now we're good. Okay, so the next thing I need to do is decide which one I'm going to cancel. So I can either cancel my x's, and if I look at the numbers I'm working with, 7 and 2, I can make them 14 and negative 14. If I choose my y's, I'm working with negative 3 and negative 1, I can make those 3 and negative 3. And what I'm going to do this time is we're going to do it both ways so that I can show you how you do get the same answer. And I keep saying it doesn't matter, but that way you'll know for sure. So we're going to start by eliminating the x's. So I'm thinking I need to make them a 14, but keep in mind they have to have different signs. So I'll choose to make the top one negative 14 and the bottom one positive 14. And so I just distribute. And I'm just going to go through this kind of quickly. And same thing on the bottom, I distribute. Okay, and I get two equations that are now ready to eliminate the x's. All right, so we're going to cancel the x's. We're going to combine the y's and combine the numbers on the right. And then you need to divide by negative 1. So you can see y is negative 9. Okay, so now that I know what y is, I'm going to use that to get x. I'm going to take the bottom equation. I like it better. I'm going to replace my y with negative 9. Of course, that becomes a plus there. And then I have to subtract 9 from both sides and divide by 2, and I have my x. So there's my solution, 5, negative 9. And I don't have to do this again, but I'm going to, just to show you what happens if you choose to eliminate the y's. For the y's, you would have to make them 3 and negative 3. Now, the top one already says negative 3, so I'm thinking I'm going to change the bottom to a positive 3. Since it's already negative y, I have to multiply it by a negative 3 to make that happen. So I'm just bringing down my first equation as is. That doesn't need to change. In the bottom one, I'm going to distribute and multiply the negative 3 on the right. And now it's all set. The 3y and the negative 3y will cancel. So let's add these equations together. I get x equals 5. So now I take that 5 and I use it to get y. I'm going to pick the bottom equation here. I'm going to make the x equals 5, and I'm going to solve this for y. Subtract 10 from both sides and divide by -1. And so my solution is 5, -9. Now just to recap, when we eliminated x, we got the solution 5, -9. And when we just eliminated y, we got the solution 5, -9. So it doesn't matter which one you choose to eliminate. Sometimes it's easier to do one over the other. That's your choice. So that's the elimination method. If you want to take a look at substitution or graphing, go back and check out my previous videos on systems of equations. I appreciate you stopping by. Please hit the like button and subscribe for more math videos. Thanks for watching.